Let's imagine something wild. A sewing needle, but not just any needle. Picture it drifting alone in the vast emptiness of space, a tiny sliver of metal against the infinite dark. Now give it a cosmic twist. Imagine it infused with the power of the universe itself. We all know a needle, tiny, sharp, and usually harmless. It's something you find in a sewing kit, not a science lab. Maybe you've pricked your finger once or twice, but that's the worst of it. It stings, but you move on. It's a tool for fixing, for mending, for creating, not for causing chaos or destruction. But what if we gave that needle the universe's ultimate superpower, the speed of light? Suddenly it's not so innocent. Picture firing this humble needle at Earth, not as a sewing tool but as a cosmic bullet, moving faster than anything you've ever seen. This isn't about patching shirts anymore. It's a mind-bending physics experiment that challenges everything we know. What happens next? Does it poke a hole, burn up, or unleash something far more dramatic and unexpected? We're about to see how ordinary objects become extraordinary when you add impossible energy and unimaginable speed. This is a journey into kinetic energy, relativity, and the potential for unimaginable destruction. Grab your safety goggles, this is going to get intense, and you'll want to be prepared for what's coming. This question mashes together two things we think we understand: a tiny, harmless needle, and the mind-boggling concept of extreme speed. The result? It shatters our intuition and forces us to see the universe in a completely new way. Sometimes it's not about size, it's about energy, and how much you can pack into something so small. And a needle at light speed? That's more energy than you can possibly fathom, enough to change everything in its path. Let's break down our two key players, the tiny, unassuming needle and the incredible, almost magical speed of light. We're about to discover just how dangerous the universe's most innocent object can become. Ready? Let's dive in and see what happens when physics gets pushed to its limits. The rules of physics are about to get weird, and nothing will look the same again. Welcome to the universe's most dangerous sewing kit, where imagination meets the raw power of physics. Meet our projectile, a standard steel sewing needle about 2 inches long, weighing just 1 gram. It's the kind of thing you might find in a sewing kit, or maybe even stuck in a pincushion. But today, it's about to become the star of a mind-bending thought experiment. It's so light you could lose it in your carpet and never notice. In fact, you might step on it and barely feel a thing, unless you're unlucky. Now let's talk speed, the speed of light. This is the fastest anything can possibly go in our universe, a cosmic speed limit that nothing with mass can ever quite reach. That's 186,282 miles per second, or about 300,000 kilometers per second. It's a number so huge, it's hard to even picture. In the blink of an eye, light circles Earth 7 times. Imagine snapping your fingers, and light has already lapped the planet multiple times before you finish. The fastest thing you've ever seen? It's standing still compared to this. Even the quickest race cars or jets are crawling at a snail's pace next to light. A bullet travels at 1 mile per second. Light is over 186,000 times faster. If you fired a bullet and a beam of light at the same time, the bullet wouldn't even make it out of the barrel before the light reached the moon. A trip to the moon for light? Just over a second. That's less time than it takes to blink or take a breath. This speed is so immense it's almost beyond comprehension. Our brains aren't wired to truly grasp such extremes, so we have a tiny, almost weightless needle, and a speed that's the universe's ultimate limit. It's a combination that seems almost absurd. When you combine any object with that kind of velocity, physics changes. The ordinary rules you're used to simply don't apply anymore. The needle stops being ordinary. It becomes a vessel for staggering energy. It's not just moving fast, it's carrying the power of a small explosion. At these speeds, the rules of the universe bend. Space and time themselves start to warp around our tiny projectile. The needle is no longer just a piece of metal. It's transformed into something extraordinary, almost unrecognizable. It's a package of pure destructive power. The energy it holds could unleash unimaginable consequences. This is where the magic and the terror of physics comes alive. The ordinary becomes extraordinary, and the familiar turns dangerous. The energy involved is what makes this scenario so fascinating. It's not just speed, it's the transformation of something simple into something awe-inspiring. Let's see what happens when you push a simple object to the edge of reality. We're about to cross into a realm where everyday logic breaks down. The universe is about to show us just how wild things can get. Prepare yourself for a journey into the extremes of physics. Hold on to that image, a 1-gram needle, moving at nearly the speed of light. It's a scenario that stretches the imagination. The consequences are anything but small. Even the tiniest object at this speed can unleash forces that defy belief. Let's see what happens next, as we push the limits of what's possible. Here's the catch. Einstein's theory of relativity tells us that nothing with mass can actually reach the speed of light, no matter how hard we try, or how much energy we throw at it. As you accelerate, your mass effectively increases, making it harder and harder to keep speeding up. The faster you go, the heavier you become, and the more energy you need just to gain a tiny bit more speed. To actually hit light speed, you'd need an infinite amount of energy, something not even the entire universe could provide. It's a hard limit, a cosmic speed cap that nothing with mass can break. But let's bend the rules for a moment. Imagine our needle is traveling at 99.9999999% of light speed, just a hair's breadth away from the ultimate limit. At that velocity, the difference between our speed and the speed of light is so tiny, it's almost impossible to notice for most practical purposes. But the kinetic energy required to get there is absolutely off the charts, far beyond anything we encounter in everyday life. Kinetic energy increases with the square of velocity, so if you double your speed, you need 4 times the energy. Push it even further, and the energy demands skyrocket. Near light speed, this effect explodes dramatically, making even tiny increases in speed require mind-boggling amounts of energy. Our 1-gram needle now carries the energy of billions of lightning bolts, enough to rival the most powerful forces in nature. It's not just a piece of metal anymore, it's become a bolt of pure, destructive energy, more dangerous than anything we can easily imagine. Even before reaching Earth, it would slam into stray atoms and dust in space, causing miniature nuclear explosions with every collision, lighting up the darkness. The needle would emit a blinding stream of high-energy particles and gamma rays, glowing fiercely like a deadly artificial star streaking through the void. It's a laser beam of destruction, vaporizing anything in its path and clearing its own way as it barrels forward at unimaginable speed. And this is only the beginning of what happens when you push the limits of physics. The needle is moments from Earth, but it won't reach the ground. The instant it hits the upper atmosphere, chaos erupts. At this speed, air molecules are like a concrete wall. The collision vaporizes the needle and air into a ball of plasma. Think nuclear explosion, not fire. Atoms are ripped apart, creating a blinding flash of radiation. The explosion happens high above, unleashing a shockwave that races outward. The sky would seem to ignite as the plasma expands. Gamma rays and X-rays bombard the surface, instantly heating everything below. Forests ignite, oceans boil, and devastation spreads across the planet-facing side. The energy is released in a fraction of a second. The first wave of destruction is pure light and radiation, and it's only the beginning. So, how much energy are we talking about? A 1-gram needle at near light speed packs about 200 trillion joules. For comparison, the Hiroshima bomb released 63 trillion joules. Our needle? Over 3 times that, just to start. Push the speed even closer to light and the energy skyrockets. At 99.9999999% light speed, it rivals the Tsar Bomba, the largest nuke ever detonated. That bomb weighed 27 tons and flattened everything for miles. Our needle, smaller than a paperclip, could unleash a similar blast. This is the terrifying beauty of E/mc2. Mass and energy are interchangeable at these speeds. The needle is gone in a microsecond, converted to a spray of particles and pure energy. What's left is a blast that rivals the most powerful weapons ever conceived, all from a sewing needle. The devastation is global. The energy isn't about the object, it's about the speed. And at these speeds, even the smallest thing can change the world. The initial flash is just the start. Next comes the shockwave, a blast wave that slams into the surface. Everything below is vaporized. For hundreds of miles, the landscape is flattened. The explosion blows a hole in the atmosphere, sending debris into space. Winds of hundreds of miles per hour sweep continents, fueling firestorms. Earthquakes and tsunamis ripple across the globe. The planet rings from the impact. Dust and soot block out the sun, plunging Earth into a cosmic winter. Temperatures plummet, photosynthesis stops, and the food chain collapses. It's an extinction-level event, like the one that killed the dinosaurs. All from a single 1-gram needle. The world is forever changed. You might compare this to a meteor strike, but it's fundamentally different. The dinosaur killer asteroid was huge but slow by cosmic standards. It did its damage through mass and momentum, creating a crater and releasing energy on impact. Our needle? It's all about energy, not mass. It detonates in the atmosphere, spreading destruction over a vast area. This is called an airburst, far more devastating for a given energy. The energy is released as radiation and shockwave, not a physical impact. It's the difference between a cannonball and a nuclear bomb. The needle becomes a concept, a tiny object delivering planet-killing energy. It's a perfect example of relativistic physics. At these speeds, energy rules everything. The needle is no longer an object. It's a force of nature, and it's unlike anything Earth has ever seen. Could this actually happen? Thankfully, no. Nothing with mass can reach light speed, and even getting close requires unimaginable energy. The technology needed is beyond anything we can dream up. Space is vast. Hitting Earth with a tiny object at these speeds is nearly impossible. Even if aliens tried, aiming would be a cosmic miracle. Nature does accelerate particles to near-light speed, cosmic rays, but they're single atoms, not needles. Their energy is huge for a particle, but nowhere near extinction level. Our atmosphere protects us from these every day, so you can sleep easy. No cosmic sewing kit is coming for us. This is a thought experiment, not a real threat, but it's a powerful way to explore the limits of physics. It shows us the universe's laws in their most extreme form, and the results are more spectacular than any sci-fi story. So, what have we learned? A simple needle, given enough speed, becomes the universe's most destructive weapon. Einstein's relativity shows us that energy, not size, is what matters at the ultimate speeds. The light-speed needle is a paradox, the smallest object causing the biggest bang. It's a reminder that every bit of matter holds unimaginable energy. The speed of light is a wall. Cross it, and the rules of reality break down. This isn't really about a needle, it's about our curiosity. It's about asking impossible questions and using science to find answers. Even the smallest things can change the world. That's the true power and wonder of science. Thanks for joining this cosmic thought experiment.